The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Hello, good evening everyone. I'm audible? Hello, good evening. Am I audible? Yes. So what were we discussing, everyone? In the last class, what were we discussing? Am I audible? Am I live on YouTube as well? Who is okay listening to the YouTube? I'm live on YouTube, right? Okay. So what were we discussing in the last class, everyone? In the last session, what are the things we were discussing? Yes, everyone, hello. What were we discussing in the last class? Hello? Hello, am I audible or not? Hello, am I audible? Yeah, we were discussing about the project requirements. We were discussing about what? The project requirements. We saw that the project what we are going to implement is nothing but micro oven. Okay, so we saw like how we are going to simulate this, like how not. We saw that what are the requirements of the project. Okay, it should be containing a screen. It should be we should be able to control the screen using the switches. Okay, then we are providing the different options. Okay, for cooking mode, we are providing four modes: micro mode, grill mode, convection mode, and the start mode. And in each mode, we are allowing the user to set the cooking time. And in the convection mode, we are allowing the user to set the temperature. Okay, once you are selecting the particular cooking mode, what we are doing is we are also allowing the users. Okay, once the cooking has started, okay, we are allowing the user to start the cooking, pause the cooking, and stop the cooking. So these are the things what we have seen in the last class. We saw the requirements. Okay, in the requirements we saw, okay, we are allowing the user to choose the different cooking modes like micro mode, okay, grill mode, okay, convection mode, okay, then start mode. After that, we are allowing, once the cooking mode is selected, we are allowing the user to set the time. Okay, set the cooking time. After selecting the particular cooking time, once the micro one is on, we are again providing the three options for the users. Okay, start and resume, pause, and and stop. Is this clear? This is what we have seen, okay, in the last hour requirements. Just a quick overview, okay, what we are, okay, discussed in the last class. Okay, so moving ahead, what we will do means moving ahead. Yes, Krishnanjali, your messages are visible. Any issues, Krishnanjali? Okay, so now what we are going to do today, we are going to discuss, okay, the embedded system. What we are going to do in today's class is nothing but we will discuss, okay, what do you mean by embedded systems? Introduction to the embedded systems. We'll be discussing the introduction to the embedded systems. Introduction to embedded systems. Okay, what do you mean by embedded system? Can you tell me what do you mean by embedded system? Yes, everyone, which are the tools you have to install? Okay, that, okay, I have put it in an announcement, and also I have shared the slides how to install it. Please do install it. Later we'll understand about what tool what are these tools doing. Okay, I have put it in the announcement. What are the tools you are supposed to install? Okay, please do install them. There is a slide for reference. Okay, if you have any issues regarding installation, you can post it in the discussion forum. Okay, you can, okay, put it in the discussion forum. Then what are these tools used for? That I will tell you later. What are these tools are used for? That I will tell you later. Okay, so we'll move on to this. Okay, move on to this thing. Okay, we'll understand now. We are going to the introduction to the embedded systems. Yes, correct. So many of you have posted. What do you mean by, okay, what do you mean by, okay, embedded system means it is a combination of hardware and software which is intended to do a specific task. It's nothing but a combination of hardware and software which is intended to do a specific task. Okay, so we'll discuss further now. Okay, so what all things we are going to discuss here in introduction to embedded system means we are going to discuss, okay, what is embedded system, okay, the definition and the components of the embedded system. Okay, so as you people are telling, okay, any combination of hardware and software which is intended to do a specific task is called as an embedded system. Okay, as you are telling, what is happening? It's nothing but what combination of, okay, hardware and software. Some are telling it's a hardware and software. It's a designed to do a specific task. Yeah, so many things are there. You can define it in many ways. Okay, someone are telling it is a specially designed, okay, it is a software, using software we are designing the hardware to do a specific task. Okay, a project using hardware and software. Okay, combination, a system functioning any device including hardware and software, that is also fine. So what is happening whenever we are talking about this definition of the embedded system? Okay, it should always have these three terms. What are the three words means? It's a hardware, it's a software. You should do a specific task. You can do the words here and there, but you make sure that always these three words are there in your okay definition. Always these three words are there in your definition. Okay, so now in order to understand this definition in a more better way, what I will do is I'll take one example. I'll just take one example to make you understand the okay definition. Okay, so let us what we will do is let us try to design an automatic gate opening system. An automatic gate opening system. Okay, automatic gate opening system. So, have you been to anytime the shopping malls or Zudio maybe or Pantaloons maybe? What will happen is, okay, when you stand in front of a glass door, will there be the glass doors? When you stand in front of that, it will automatically open, and when you pass by, it will automatically get closed. Have you seen such doors? Have you seen such doors? Automatic gate opening systems. Have you seen such automatic gate opening systems? Huh. So same thing, yeah. It may be in airports, in metro, okay, rail doors, okay. Yeah, you have seen. So what is happening? Let us try to okay design such gate opening system. Design means we'll just list down the components. And my requirement here it should be purely hardware. It should be what? Purely hardware. That is my requirement. Okay, so if I try to list down the components, if I try to list down the components, design means not writing the code. Okay, we'll just list the components required to design this. So can you tell me what all components maybe I require to design this automatic gate opening system? What all components I may require to design this automatic gate opening system? Yeah, we require a sensors, correct. Okay, to check the presence, to check the what presence. Okay, we require what sensors. Okay, first thing is I require a sensor. Sensor to sense the motion. Okay. Then after sensing to sensor to sense the motion, you can use ultrasonic sensor, you can use PIR sensor. A sensor is used to sense the motion. Then someone is telling me to use microcontroller. See, my requirement here is pure hardware. Okay, microcontroller is a hardware, correct? But in order to program that, okay, hardware, we require a software. Okay, so I don't want to use any software here. So I cannot use any microcontroller here. Okay, so first thing is sensor. After sensor, what do we need? Okay, yeah, sense. After sensing, what I have to do is I have to compare that value. Okay, I have to compare the value. So I need what? Comparator here, whether it is true or false. Okay, we need a comparator. The coming signal. Okay, to compare that, I need a what? Comparator. Okay, after comparing, what we have to do is open the gate and close the gate. Yeah, to open the gate and to close the gate, we require motors. Then motor, servo motor, DC motor. Okay, we have different stepper motor, different types of motors are there. Now, when I'm talking about motor, to drive the motor, we need a driving circuit. So here I'll take the driving circuit as a relay, okay, which will turn on the motor and turn off the motor. I'll take here it as what? Relay. Okay. Then how long my okay, gate should be open, how long the gate should be closed. Okay, for that I will keep here what? Timer as well. I will have what? Timer. Okay, a 555 timer. It's a hardware. Okay, I will use here what? Timer. Sensor, comparator, relay, and timer. See here, we are not connecting these things. We are not writing any code. We are just trying to list down the components required. Okay. So these many components are enough for me to design a, okay. Okay, these many components are enough for me to design an automatic gate opening system. Are these components enough for me to design an automatic gate opening system? Yes or no, everyone? Are these components enough for me to design an automatic gate opening system? Yeah, power supply, glass door, that all human being I'm not considering, just the components. Power supply, we need a power supply, we need a gate, we need a glass door, we need a human being, yeah. We need a cables also, correct? But for now, to design from okay perspective of design, are these components enough for me to design an automatic gate opening system? Yes, these components are enough. Okay, I don't need a controller here. I don't need a controller here. Controller not required. Okay, and I cannot use controller because already I told you here my requirement is pure hardware. Okay, if I'm using a controller, it requires a software code to run. So I cannot use a microcontroller here. Yeah, now tell me whether this is an embedded system or not. Whether this is an embedded system or not. Is this an embedded system? It's not an embedded system. It's not an embedded system. Why? Because here is what our definition is telling. Our definition is telling it's a combination of hardware, okay, and it's a combination of software, and which is intended to do a specific task, which is intended to do a specific task. Is it a hardware? Yes. Is it a hardware? Is it a hardware? Yes. Is it doing a specific task? Yes. Yeah, it's opening the gate and closing the gate. Yeah. Then is it being run by the software? Is there software present? No. So because of this, this is not an embedded system. This is not an embedded system. Okay. Here, what I want to tell you is, okay, see any system that is automatic, any system that is running on a, okay, electricity is not embedded system. Okay, there will be hardware, it is doing a specific task, but there should be a coding part present in that. There should be a coding part present in that. There should be a software present in that. Then only we call this system as an embedded system. Getting my point? Yes. Yeah. So now what is happening? This is not an embedded system. Okay. So now in your home, okay, if you are sitting, okay, below the fan, so is your fan embedded system? Is your fan embedded system? Is your fan embedded system? Is your fan, okay, you are sitting below the fan, is your fan embedded system? No, it's not an embedded system because, okay, fan, is it a hardware? Yes. Okay, is it doing a specific task? Yes. But is there any software code running inside your fan? Is there any software code running inside your fan? No, right? So it is not an embedded system. Suppose if your fan was a smart fan, okay, if your fan was being controlled by the remote control, okay, then coding will be present in that. That time it will become an embedded system. That time it will become what? Embedded system. Yes, Shreya, correct. So if you're connecting your fan to the internet and trying to control it through the phone, yes, then it is a embedded system. Then it is what? Embedded system. If you are trying to control it from phone, yeah, it is an embedded system. Got it? So what I want to just conclude is whenever you're calling any system as embedded system, just go through the make of it. Yeah, it should be a hardware, it should be doing a specific task, okay, and it should be there should be a software code running inside that. There should be what? A software code running inside that. Then only we call it as an what? Embedded system. Is this clear, everyone? Yes. Okay, fine. Yes, Prajwal Kamli, what is your question? LMS login, you please post in a discussion forum. I don't have, okay, you don't have LMS login. Please, okay, connect to the support team. I cannot create it. I don't have access to that. You please connect to the support team. Please mail it to the support team. I will also tell it from my end. Please, you mail it to support team. Okay. Yes, fine. If this is clear, everyone, can you give me few examples for embedded system? Can you give me example for embedded system? Okay, washing machine, correct. Laptop is not embedded system, Shubham. Okay. Washing machine, okay. AC, robo. IoT is one technology, it is not one system. Okay, traffic lights, correct. ATM machines, smart TV, auto irrigations, okay, remote control lights, fans, elevators. See, who are having queries regarding LMS or anything, please wait. Okay, I will discuss at the end of the session. I don't want to deviate from the session. You have any other queries? Please wait till end. Okay, at the end we will discuss. Okay, you wait back, you ask your questions. Don't okay don't disturb the okay flow. You have questions, please do wait. Okay, at the 5 minutes, I'll just keep it for your questions. You can ask me later. As of now, don't ask the other questions. If you ask also, I will not respond. Let me repeat one more time. You have any other queries other than class, wait after the class for 5 minutes. We will discuss. In between the class, if you are posting the questions, I will not respond. Yeah, smartwatches, micro oven, correct? Airbags, televisions, okay. Pacemakers, correct. Drones, very good. Okay. Lift, very good. Okay. Laptop is not a embedded system, Krishna. We will discuss it. Okay. Atul is asking why. Okay. Laptop is not an embedded system. We'll discuss. Dishwasher, correct. Okay. Then water dispenser, correct. Water dispenser. Okay. Drones. Okay. Earphones, correct. Yeah, everyone good. Good. Your all examples are fine. Yeah, AC is an embedded system because you control your AC through okay, mobile phone, or you can control it through your remote at least, right? And it will be reading the temperature, it will be setting the temperature, it will stop, okay, increasing the cooling based on the temperature reading. Yeah, AC is a smart, means code is there, okay, temperature sensor is there. Okay, so AC is a okay embedded system. EV is also embedded system. Okay, so some example from my end as well. Okay, yeah, we have a okay micro oven, washing machine, okay, smart TVs, CCTV surveillance, okay, then refrigerators, Okay, then we have smart gadgets. Okay, in automotive electronics, in robotics, in avionics, in medical industries, in storage devices, the rovers, space rovers, routers, missile system, mobile phone. So these all are nothing but examples for what? Embedded systems. These all are nothing but what? Examples for embedded systems. Okay, now we'll proceed further. Yeah, some people are asking me the question, why not laptop is an embedded system? So we have two types of systems when it comes to the your systems. Okay, one is embedded system, one is GPS, general purpose system. GPS, general purpose system. Yeah, when it comes to embedded system, it's nothing but what is a combination of hardware, software doing a specific task. We have a hardware, we have a software which is doing a specific task. But when it comes to general purpose system, right? Okay, this is okay, actually hardware, it is also having a software. But what is this system means? This is a system which is used to, you can define it as what? Which is used to develop, which is used to develop other embedded systems, okay, which is used to develop other embedded systems itself and itself. General purpose systems are those systems which is used to develop the embedded systems and itself. What is GPS? GPS is a general purpose system. A general purpose system is nothing but which is used to develop the embedded systems and itself. Example, okay, if you take your laptop, see using laptop only, what will happen? You will develop a okay washing machine. Means you will write the code for washing machine using your laptop. Okay. Then if you take the example of your micro oven, you develop it using what? Laptops. So here examples are nothing but what? Laptops. Now, can I use washing machine to okay develop another washing machine? Can I okay use a micro oven to develop another micro oven? No, right? So they are all what? Embedded systems. They all are what? Embedded systems. General purpose system is a system which is used to develop okay other embedded systems and itself. See, laptop also is developed using laptop. Okay, because why? Laptop is having a screen, we have enough memory, we can change the memories, we can also type the code, compile the code, execute it. Okay, so what is happening? Okay, it is used for what? Development. It is used for what? Development. So we call it as what? General purpose system. We call it as what? General purpose system. Is this clear? Why laptop is not an embedded system? Is it clear? No, there is one more example, mean desktop only, nothing else. We have desktop and laptops. Only the okay, these computers are used for general GPS, not other, no other examples. Likita. Fine. Next, what we are going to discuss is components of the embedded system. What we are going to discuss, sorry, categories. Categories in the embedded system. So, what are the different categories we have in embedded system? We have standalone, real time, network, and mobile. So, these are the four categories we have in the embedded system. Okay, first one is what? Okay, standalone. Can you guess what can be the standalone category? Can you guess what is the standalone category? Yeah, single, independent by itself. Yeah, actually, standalone is having two perspectives here. Actually, one perspective is slave type. It is a slave type. One perspective is take decision on its own. Okay, it doesn't wait for anyone. Take decision on its own. Yeah, what is a slave type means is just follow the command blindly. It follow the instructions blindly. Follow the instructions blindly. Follow the instructions blindly. Follow the instructions blindly. That is nothing but slave type. Okay, example, if you take a semi-automatic washing machine, if you take example of semi-automatic washing machine. Semi-automatic washing machine. Yeah, in a semi-automatic washing machine, assume you are putting the clothes. You are putting what clothes? And you did not supply any water. You did not provide water to that semi-automatic washing machine. Yeah, but you turn it on. What will happen? You turn it on. You don't supply water and you turn it on. What will happen? Yeah, it will start spinning without water also, correct, Mohammed? Yeah, what will happen? It will not throw you error. It will not throw you error. Okay, it will not throw you error, Monisha. The semi-automatic washing machine, it will start rotating. It will start rotating even though you don't supply any water. Okay, that is nothing but following the instructions blindly. Okay, what will happen? It will just follow the instructions blindly. Okay, you don't, it doesn't throw any error, it will just follow the instructions what blindly. They are called what? One perspective is standalone slave type. Example, micro oven also. What will happen in the micro oven? You don't keep any food. You start, okay. It will turn on. It will not tell you have not kept the food. Okay, micro oven also. Okay, you don't keep any food. If you don't keep any food also and turn it on, what will happen? Okay, it will start working. Okay, so it will not give you any error. You just give the command and it is following the instruction blindly. That is one type of perspective. Second, one more perspective is take decision on its own. Example, okay, the self-driven cars. The self-driven cars. What will happen in case of self-driven cars? So in the self-driven cars, you just provide what destination? You just provide what destination? Assume you have put the destination as airport. So in the path, what happened? Okay, there is some accident or there is some traffic congestion. So what the self-driven cars will do means it will reroute itself. Okay, it will reroute itself. Okay, if the path is not available, the going path is not available, it will reroute itself. It will not ask for anybody's permission. Okay, what it will do, it will reroute itself and just send you the notification that rerouting. It's rerouting, it will send you the notification. It will not ask for any permission, or it will not ask, okay, here traffic is there, what should I do? Here, okay, the road construction is going on, what should I do? It will not ask for any input. It will take the decision on its own. There are two perspectives of standalone category. One perspective is slave type, which will follow the instructions blindly. One more, okay, one more perspective is take decision on its own. That is called what? Okay, that is one more perspective. Example here, self-driven cars. So this is the first category. Are you clear with this first category? Are you clear with the first category? Clear? So next is nothing but what? Real time. So what do you mean by real time? What do you mean by real time? So real time is nothing but where your task gets completed within a given deadline. Where the task will gets completed within a given deadline. Yeah. Yes. Okay. So what is happening? We have real time embedded systems are nothing but what? Where the task should get completed. The task, okay, should complete the within a given deadline. Within a deadline. Okay, it's not like without delay. Okay, whatever deadline is there. See, sometimes people will think real time means automatic. Okay, not automatic or not instantly. It should not miss the deadline. It should not miss the deadline. That is what is called as real time. So deadline can be like milliseconds, nanoseconds, anything, but the deadline should not be missed. Okay. So based on this deadline, okay, what happens if the deadline is missed, or how critical is the deadline? How critical is the deadline? Based on that, again, we have three categories in the real-time embedded system. One is hard real time. Next is soft real time. Okay, then firm real time. Okay, so what is this hard real time? Okay, 1 minute. Okay, so here what will happen? Hard real time. Okay, here what is happening in the hard real time? Here the deadline is critical. Here deadline is what? Time critical. If the deadline is missed, if the deadline is missed, what will happen? Okay, hard real time. What will happen if the deadline is here? If the deadline is missed, it is going to affect the human life. Here it is going to affect what? Human life. Okay, here human life critical. The deadline is human life critical. Okay, what will happen here? Okay, human life critical. So what will happen here? If the deadline is missed, it is going to cause damage to the human life. Okay, so example I can tell here, the airbag system. Example here is what? Airbag system. Airbag system. Example here is what? Airbag system. So what happens in case of airbag? Okay, what happens if the airbag deadline is missed? If it doesn't open up within a given deadline, what will happen? What will happen if the deadline is missed in case of airbag? Everyone, I hope you are aware of airbag. Yeah. So what is happening? It will may cause death to the human being. So what will happen? They are called hard real-time embedded system. Can you give me such examples? Can you give me example if the deadline is missed and it's going to be affecting to the human life? Can you give me such examples? Can you give me an example? See, micro one deadline is missed, nothing will happen. Parachute opening, parachute is not an embedded system. Is parachute a embedded system? Is there any hardware? Is there any software running inside a parachute? You can design one if required. Yes, aircraft, fine. Emergency, correct. Pacemaker is correct. Fire alarms are correct. Pacemaker, fire alarm, correct. Smartwatch, how smartwatch failure will affect the human being life? No smartwatch. Yeah, gas leakage detection is correct. Jet emergency is correct. Am I not audible? Am I not audible? Screen disconnected. Hello, am I not audible? Is screen not visible? Yeah. Then soft real-time embedded systems are those, okay, here what will happen? No damages. Okay, here no damages will happen. No damages will happen. No damages will happen here. In case of what? Soft real-time. If the even the deadline is missed, no loss. Okay. No loss. Example. Okay, you set the washing machine timing as okay 10 minutes and it was working for 15 minutes. Okay, washing machine, what is happening? You set the work, okay, time as 10 minutes, but it is taking 11 minutes. It's okay, no? That is called soft real-time embedded system. No damages will happen. It's okay. Okay, we have tolerance towards this. Even the deadline is missed, no damages will happen. Firm real-time, what is happening means it's going to cause damages to the, it's going to cause damages to the, okay, health and, okay, sorry, the money and finance, money and property. It's going to cause the damage to the money and property if the deadline is missed. If the deadline is missed, what is happening? It's going to cause okay damage to the money and the property. Example. Okay. Here, what is example means? Okay, the rovers, space rovers. So what will happen? Space rovers. Okay, what is happening there? The Chandrayana 1, Chandrayana 2. What happens if they fail? Okay, what happens if they fail? Okay, no, okay, life damages, but what is happening? Whatever investment made on that, whatever investment made on that, it is gone. Okay, example, people are working day and night on that. Crores of investment going into the space rovers. If it fails, all the money gone. Okay, so they are called firm real-time embedded system. So in the real-time embedded system, we are having three categories: hard real-time, soft real-time, and firm real-time. In the hard real-time, okay, life critical if the deadline is missed. In the soft real-time, even the deadline is missed, okay, no damages are happening. In the firm real-time, if the deadline is missed, it is going to cause the damages to the property and the money. Okay, fine. Then next what we are having is networked. Networked embedded system. What do you mean by networked embedded system? Okay, network embedded systems are those systems, okay, which are getting connected to the multiple devices, which gets connected to the multiple devices and okay, exchange the data, which gets connected to the multiple devices and exchange the data. Okay, get connected to the other embedded system and exchange the data and exchange the data. Get connected to the other embedded system and exchange the data. That is called network embedded system. Here, yeah, example here, routers. So what will happen? The routers, the Wi-Fi routers, they get connected to a different embedded system and exchange the data. Wi-Fi routers, or it can be your Bluetooth speakers, your Bluetooth headphones. They get connected to the multiple devices and exchange the information. So they are called network embedded system. Then next, what we are having one more category, mobile. So mobile means which can be movable from one place to another place. Okay, mobile embedded system are portable embedded systems. Okay, which you can carry from one place to another place. Portable embedded systems which you can carry from one place to another. IoT is something different technology, okay? Okay, fine. Yes, I'm audible. Some people are telling my screen is stuck. Do you have any issues with my screen, everyone? Do you have any issues with my screen? Okay, I'll tell you. I'll come to that, Adhiraj. Yeah. So for this example is nothing but mobile phone. Your mobile phone. Okay, example. Now, when you consider any embedded system, right, it is falling under more than one category. Then we call them as what? Hybrid embedded system. If an embedded system is falling under more than one category, we call it as a hybrid embedded system. Example, if you take your Bluetooth speakers are connectable also and you can carry it from one place to another place as well. So that time what will happen? They come under this hybrid embedded systems. Okay, they come under this hybrid embedded systems. The embedded systems is falling under more than one category. Okay, then we call it as what? Hybrid embedded system. Clear? So totally we have actually 5 categories: standalone, real time, network, and mobile. Standalone, real time, network, and mobile. So if the embedded system is falling under more than one category, we call it as what? Hybrid embedded system. We call it as what? Hybrid embedded system. Is this clear, everyone? Everyone, are you clear with this? All the four, five categories? Are you clear with this? All the five categories, everyone? Mobile is the embedded system. Okay, Sharvesh is asking whether mobile is a GPS or yes. Mobile is the embedded system because you cannot use mobile for development. You cannot use mobile for development. Hybrid system if the any embedded system is falling under more than one category. Is falling under more than one category. If the embedded system is falling under more than one category, then we call it as what? Hybrid embedded system. Wi-Fi router will become networked. It will not be hybrid. It is a network. Okay. EVs are nothing but mobile. EVs are mobile. Fine. Is this clear, everyone? So yeah, we will stop here for today. Okay. So we understood the definition. Okay. What we did was we saw what is embedded system. We took one example. Okay. To see. Okay. How to understand the definition of the embedded system. We saw a few examples for embedded system. We saw what is the difference between embedded system and the general purpose system. Then we saw the categories of embedded system. Okay. Okay, we'll stop here for today and we'll continue in tomorrow's class. Many things will continue in tomorrow's class. Yeah, fine. Thank you, everyone. Good night. You can leave. Okay, tomorrow we'll continue with the components of the embedded system. Tomorrow we'll continue with what? Components of the embedded system. Sahil, IoT is a, okay, embedded systems are the part of IoT. Okay, whatever we have done this embedded system, if you are connecting them to internet, they become IoT. These embedded systems, if you connect them to internet, they become IoT. So who has not received? Okay, you have not received offer letter. That thing I'll okay inform the okay dish marketing team. They will take care of it. Okay, I'll inform about it. You also mail it. I'll also inform them. Okay, about the offer letter. Then how to log in LMS? He'll be having a user ID and password. You can log in. Okay, Vijay Kumar. Yeah, mobiles are under network also. They'll come actually in hybrid. Mobile will be under hybrid because it is mobile also, it is networked also. Likita. You can ask your this question here. You can go to the LMS, log into the LMS. Okay, log into the LMS. Go to your course. Go to your course. Here we have discussion forum. There post your question. You have a discussion forum in the LMS login. Okay, there you post your question, Shobana. LMS login link you might have shared it through, you might have got it through email. See, you are having issues regarding LMS login. You have to send a mail only. I cannot help about it. Okay, there is separate team who is taking care of it. Please mail, send a mail. Okay, I'll ask them to respond as soon as possible. Now we are going to use embedded C, Sudhakar. Okay. Whoever is not getting mail, I'll talk to them. Okay. I'll contact the marketing team. They will okay reply to your mails. Okay. Fine. Yes. Thank you, everyone. We'll meet tomorrow.